All right, this lesson is going to go over the 9.2 homework. And starting with number 1 here. So in exercises 1 through 10, state which conjectures definitions you used. So first of all, they're asking you what's the measure of this arc right here. Well, you'll notice how this is an intercepted arc here. And so the central angle is 165, and so x measure of that arc will also be 165 degrees. And that's because the measure of the arc, so the measure of the intercepted arc equals the measure of the central angle. Okay. In Z, we can see that we have this chord is congruent with this chord. So this is 128. That measure of that arc will also be 128 degrees. And we know that an entire circle, the measure of that arc is 360. And so Z will equal 360 minus 128 minus 128 minus 20. And so Z will equal 84 degrees. The conjectures, it asks you to state which conjecture definitions you used here. So this being 128 comes from the chord arcs conjecture. And that's from, looking at my notes here, what's that from? That's from investigation 2. If two chords in a circle are congruent, then their intercepted arcs are congruent. And we also use the fact that there are 360 degrees in a circle. So 360 degrees in a circle. We also use that as well. Okay. Next is number 3. Number 3, again, we have two congruent chords, and we're trying to find W here. And this is 70 degrees. And so W will also be 70 degrees. And that's because of the chord central angles conjecture. Let's see what investigation is that from. Investigation 2. If two chords in a circle are congruent, then they determine two central angles that are congruent. Okay, number 4. AB is congruent to CD. So these arcs right here are both congruent to each other. PO is equal to 8 centimeters, and that means, since these are perpendicular here to two congruent arcs, that this will also be 8 centimeters. And that's because of the chord distance to center conjecture. Let's see. That's from investigation 3. If two congruent chords in a circle are equidistant from the center, or two congruent chords in a circle are equidistant from the center of the circle. So if we have two congruent chords, they are the same distance from the center. Always. So two congruent chords are always the same distance from the center of the circle. Okay. Number 5, let's see. So this right here is 68 degrees, and these are both radii, so those are congruent. AB is a diameter. I'm trying to find the measure of arc AC. Well, the measure of arc AC is going to be the same as the central angle, so that's 68 degrees. The measure of angle B, right, so this arc right here is also 68 degrees. And let's see, the measure of angle B, which I assume is this angle right here. Oh, look at that. We have an isosceles triangle, right? These are going to be the same. So this angle right here, that angle right there, is going to be 180 minus 68. So that's 180 minus 68, which equals 112. And so B will be equal to 180 minus 112 divided by 2, which is 68, divided by 2, which is 34 degrees. And there you go. To do this, let's see. We used a couple things. So this, we use the fact that the intercepted arc equals the central angle. The measurement of the arc is central angle it intercepts. And with B, we use the fact that the base angles of isosceles triangles are congruent. A